Welcome to the Project Management Prepcast, your guide to PMP exam success. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to part 2 of our lesson on earned value management. In part 1, we went through an introduction to earned value management and looked at the basic earned value management formulas. And now in part 2, we are moving on to the more advanced topics and advanced formulas of EVM. We begin with a review of the various abbreviations and 2 formulas that we have already learned about in part 1. The first one is, of course, Earned Value Management, or EVM. This is the general method of earned value. Then AC is the actual cost. This is how much it has actually cost us to create a work package to complete the project. PV is planned value. Well, that's the authorized budget assigned to scheduled work. It is what we plan to spend in order to produce a certain deliverable. Then we have EV, which is the earned value. That is the theoretical value that our project produces for our company as we deliver these work packages one after the other, and the deliverables as well. And with these 3 figures, AC, PV and EV, we can then calculate the cost variance, where cost variance is EV, earned value, minus AC, actual cost. It will tell us whether or not we are ahead or behind our budget, or rather above or below our target budget. If you want to know whether or not you are ahead or behind your schedule, well, you're going to have to calculate schedule variance, which is EV minus PV, translates to schedule variance is earned value minus planned value. And when we compare the variances versus the index formulas, which we'll learn about in this lesson later on, we see that if we want to calculate the variance, we subtract the numbers, and if we want to calculate an index, we're going to have to divide. We covered this little memory aid there, the very last slide of part 1 of our introduction to earned value management. Then it was just a sneak peek. Let's now move along and cover performance indices in greater detail. When working on a project, it is reasonable to ask, overall, how efficient and productive are you and your team? Are you facing different challenges that affect your performance? Perhaps it's bad weather, delay in procurement of resources, or lack of training or experience with a particular process or computer system. And note that when we asked about performance, we did not ask if you were working fast, as it's not necessarily about speed. Working too fast, perhaps your work is more prone to errors, which may then cause work to have to be repeated or using up more resources. So you can see it's a bit of a battle of time versus quality, or cost versus quality. Overall, when we say performance, we are trying to balance out scope, cost, time and quality, as they are the most interrelated ones. We are next going to cover different performance indices, which are there to better understand if you are achieving the level of performance that you planned for. These indices are a bit more useful than just the variance values in identifying trends. Let's take a closer look at these indices in the next few slides. The first index that you must be able to calculate for the PMP exam is the Cost Performance Index, the CPI. This is also sometimes known as your run rate or your burn rate. This is a measure of cost efficiency on your project, and it is the ratio of earned value to actual cost, and it is calculated simply by dividing earned value by actual cost. Now, what an index does is it gives you a measure of comparison across different projects. So, if we, for instance, take a very large project and we have a cost variance of $2 million on that large project, and then we have a small, tiny little project with a cost variance of just $300, well, we don't really know what that means. Is the large project doing better, or is the smaller project doing better? Because The variance is just a number. It's a dollar amount. Yes, it's much larger on the large project, but what does that mean in percentage points? And this is where the CPI helps you. If you have a CPI of 1.1 on a large project and a CPI of 1.2 on your teeny tiny little project, you can get a better feel for what this means, because you can actually compare these two indices. For completeness sake, here are also the abbreviations for the cost performance index formula. CPI obviously stands for the cost performance index. Then we have EV, which is earned value, and AC, which is actual cost. And you should remember EV and AC from our part 1. And of course, if CPI was the cost performance index, then SPI is the schedule performance index. This is the second index that you must know for the PMP exam. You must be able to calculate it. It is a measure of schedule efficiency on a project, a ratio of the earned value to your planned value. Again, the index allows you to compare multiple projects to each other, and it's also much easier to understand what's going on. If I tell you that you have an SPI of plus 1.5, or I tell you have an SPI of minus 1.5, you instantly get a feeling that, wow, with this number, plus or minus, I could quickly determine whether I'm in the positive or whether I'm in the negative. Well, how's it calculated? Simple. It's calculated SPI equals EV divided by PV. So earned value divided by planned value. That gives you your schedule performance index. Again, the abbreviations, you should already be aware of these by now. SPI, schedule performance index, that's a new one, but EV and PV, earned value and planned value, we learned about in part 1 as well. In addition to knowing the formulas and being able to apply them to exam sample questions, it's also important for you to be able to interpret what the results mean. For example, if I tell you the cost variance is minus 5,000 Swiss francs, what does that mean? Well, let's take a look at how to interpret these numbers. It's really quite easy. For cost variance and schedule variance, anything positive is good. It means that you are under your planned cost or you are ahead of your schedule. Zero variance means that you are on target. You're either right on cost or right on schedule. And of course, negative, the negative variance means it's bad. It means that you are over budget or you're behind schedule. And then for the cost performance index and schedule performance index, we're talking about a single number here. If that number is above 1, it means, well, it's good. It means you're under budget and you are ahead of schedule. If the number is exactly 1, that also means it's good, which means you're exactly on budget, you're exactly on target with your schedule. And if the number is below 1, if the index you get is smaller than 1, well, that's bad. It means you are over budget, you are behind schedule. Let us shift our attention from performance indices to forecasting, and the PMBOK guide defines forecasting as an estimate or prediction of conditions and events in the project's future based on information and knowledge available at the time of the forecast. The PMBOK guide definition continues to state that the information is based on the project's past performance and expected future performance and includes information that could impact the project in the future, such as estimate at completion and estimate to complete. We will explain what is meant by estimate at completion and estimate to complete in a little while. Already we note that with words such as estimate, prediction and future, that the forecast is not 100% certain. It's an approximation based on assumptions and based on what is known at the time of the forecast. Let us reflect and try to understand the motivation behind forecasting. Well, we forecast because there are quite a lot of important questions you or other stakeholders may have as you're going through your project, like what is the expected total cost of finishing the project? What is the expected cost to complete the remaining project work? Or what cost performance is required with existing resources to deliver the project as promised? Other questions related to forecasting include what's the expected cost variance at completion? How do I measure work achieved in terms of my approved budget? And how do you estimate the amount of work that is completed to date? In this presentation, in this lesson, we'll work through how the different forecasting formulas answer each of these 6 questions. Let's go back to our first and second question. Both of these are focused on project costs, and these questions, they relate to 2 earned value management terms, which are estimate at completion and estimate to complete, respectively. The estimate at completion, or EAC, is today's forecasted estimate for the total cost of the project for when it is done. This one answers the question, what's the expected total cost of finishing the project? The estimate to complete, or ETC, is today's estimate for the cost of all the work that remains to be done in the project to get it to completion. It answers the question, what's the expected cost to complete the remaining project work? Your next question is likely going to be, well, how do you calculate these? What's the expected total cost of finishing the project? In truth, the answer to that is, it depends. In coming up with your estimate at completion, you have different options on what formula best applies depending on the situation that you find yourself in on your project. And there are 4 scenarios. Scenario A is to re-estimate. In this scenario, original estimates are known to be highly inaccurate. Perhaps assumptions on which the original estimates were based, they no longer apply, or original estimates, they were fundamentally flawed, perhaps due to poor estimation techniques. No matter what the reason, experts want to discard the old estimates and create a new one. Scenario B, then, under this situation, you want to use the planned rate, as you deem that the original budget is more accurate than your current project performance. You consider variances that you have experienced so far. They're unusual, and such variances are unlikely to continue for the remainder of the project. For example, you know that you are above budget because 3 of your engineers have been sick with a cold for 10 days last month. That's why your numbers are off. But now that the flu season is over, you don't expect to have such a major loss going forward. Scenario C, in this scenario, you want to use the current cost performance index, since you can rely on your current cost performance efficiency, but not on the planned rate on which the original estimate was based. For example, you know you are ahead of schedule because expected technical complications did not arise. Your engineers don't really expect any issues going forward, so you expect the current favorable progress on your project is going to continue. And then finally, scenario D, here you are trying to consolidate both the cost performance index and schedule performance index as you are calculating your new estimate at complete. One of the situations wherein you'd need to do this is when your project is over budget, but you still need to meet a schedule deadline. In calculating the EAC in this way, you want to make sure you consider both the cost overruns and the fact that you must deliver your project on time. Let's now review all of these 4 scenarios in detail, beginning with scenario A. This is where you want to re-estimate, as we cannot rely on our original estimates. The experts or the stakeholders who gave you the original estimate, they realize something was wrong. They may want to revisit, revamp, completely change the original baseline duration and cost because something was just wrong. We need to throw this away. By pure definition, we know that the estimate to completion is estimate at completion less actual cost. So yeah, we know we planned $500,000 was our budget. We've already spent $400,000. Well, $100,000 is left. That's the estimate to complete. But we know that our estimate at complete there is inaccurate. We just determined our budget is completely wrong. We have to do something else. We cannot recalculate the ETC. We need a bottom-up method where we re-estimate the remaining work. So we simply say, okay, our estimate to complete, we have to re-estimate this. How much work is left to do? Let's do a new estimation. In terms of a formula, this implies that in order to arrive at your estimate at completion, how much is going to be our final budget, you need to add up what you've already spent so far and what you are still going to be spending. So this means that you have to add your actual cost to your new estimate to completion, the one that you have just re-estimated. So how much have we spent? How much are we thinking now, estimating now that we're going to be spending? That bottom-up estimate to completion, add those two together, and you get your new final budget. Again, use this particular formula for the estimate at completion if you know that your original estimate was wrong. Something went wrong in the original estimate. You have to throw it away. Conditions have changed. The conditions are invalidating your original estimating assumptions. You have to start bottom up. You have to re-estimate. Let's examine this bottom-up estimate to complete a bit more. If I ask you, how much is your project going to cost until you finish it? You can probably give me some kind of a number. You can estimate how much work is left and you multiply that by the hourly rate. This is a simple example, of course, but it is what you do for a bottom-up estimate to complete your project. You re-estimate everything that you have and you come up with a new calculation of what is left. That will give you a more accurate estimate to complete. Now you can use the formula that we just introduced. Estimate at completion is your actual cost plus the bottom-up estimation that you've made. For instance, if you know that your actual cost is 100,000, that's how much we spend until today, and we have just recalculated a bottom-up estimate to complete is 20,000. In other words, you'd need to spend an additional 20,000 to finish the project. So together, 100,000 already spent. The 20,000 new one is 120,000. Our revised estimate at completion is 120,000. But there are a few problems with this particular re-estimation method. First of all, it takes time. As you know, the time that you and your team just spent re-estimating the project cost, that is lost and it can never be regained. Re-estimation is also costly. Every hour that you or your team spend re-estimating, well, that is added to your project cost, and you probably don't have a budget for that. So how about if you want it quicker and cheaper? In this case, we can use various other earned value formulas and use earned value data to calculate our estimate at completion. Which means we are moving on to scenario B, where we want to use the planned or budgeted rate. This is because we believe that the original budget that we have still holds true and any variances we currently experience are unlikely to occur again. Remember, this is the one where you had your 3 engineers that were out sick and now the flu season is over and everything is going to go back to your original budgeted rate. So here is the formula. It is estimate at completion is your actual cost plus the budget at completion minus your earned value. And in terms for the abbreviations, it means that EAC is the estimate at completion. AC is our actual cost. We take that. We add to this our original budget, which is the budget at completion, and we subtract how much we would have theoretically earned on our project as of today, which is our earned value. Note again that this formula only makes sense if future work will occur at the planned rate, which was used when we set up our original budget. So in scenario B, we said our current project performance is wrong. We have to use our planned performance to calculate estimate at completion. And here in scenario C, we do exactly the opposite. We say our planned performance is wrong. We need to use the present CPA to calculate our estimate at complete. And here is how we do this. It is EAC equals BAC divided by CPI. As we know that our current performance is correct and our original budget at completion can now be used, and we modify this with the cost performance index. So we take our original budget, the budget at completion, and divide that by our current performance, and we will get a pretty accurate new estimate at completion. Here once again the abbreviations for this formula. We have the estimate at completion, we have the budget at completion, the BAC, and of course the CPI, which is the cost performance index. And note that you should use this formula only if you expect that the same cumulative cost performance index is going to apply for the rest of the project. In other words, the current project performance is what we're expecting to continue until the project is over. And now we're moving on to scenario D. Here we need to consider both the cost and the schedule performance as we are calculating a new estimate at completion. One case in which this is applied, if you hear that, well, we're above cost, but we have this fixed delivery date and we have to deliver our project on that date, no matter that we're above budget. And here's the formula, and this is really one of the most advanced formulas that you need to know for the PMP exam. It is estimate at completion equals actual cost plus the budget at completion minus earned value divided by the cost performance index multiplied by the schedule index with 2, 4, 6 brackets around them in order to make it work properly and mathematically. So what are we looking at here? Let me give you the concept behind the idea of the formula. So it's really quite simple. We really take the actual cost and we add a single number to the actual cost. And this number factors in both our planned numbers. The budget at completion is a planned number minus earned value, which is how much our project has produced or earned up to this point. And then we factor in both cost performance as well as schedule performance. So cost performance index multiplied by schedule performance index. If you do this right, then you will get an estimate at completion that takes our current figures and modifies these figures with our current performance. This is the complete performance which factors in both cost performance index and the schedule performance index. Overall, this gives you an estimate at complete that is based on your planned figures as well as your current figures. For completeness sake, let's make sure that you understand all the abbreviations that we use in this quite complex formula here. So we have EAC, which is estimate at completion. We have AC, which is obviously the actual cost. We have BAC, our budget at completion. EV is earned value. CPI is the cost performance index, and SPI, the schedule performance index. Let's do a review of these estimate at completion formulas. The first one has to do with re-estimation, where EAC is the sum of your actual cost, and then to that you add a new bottom-up estimate to complete. Then the next one is when we calculate the estimate at completion at the budgeted rate. Use these formulas if the variances that you are experiencing on the project will probably not occur again, and you expect that future work will occur at the planned rate that you originally planned for your project. You calculate this by taking your actual cost plus your budget at completion minus your earned value. The third formula is to calculate the estimate at completion based on your current performance index from the cost. You see that EAC is calculated as budget at completion divided by your cost performance index. Use this formula if you can rely on your current cost performance efficiency, but not on the planned rate on which the original estimate was based. You will probably have noted that underneath the formula that we've reviewed, we've also inserted a formula that we haven't yet seen. Let me explain this one briefly here. It's a formula you need to know for the PMP exam as well. So we know that your estimate at completion is actual cost, how much have we spent today, plus how much are we going to spend until the end of the project. So we have that already there. So estimate at completion equals actual cost plus, and then what's in those four brackets is your estimate to complete adjusted by your cost performance index. So what we're doing there, we're saying that our current cost performance index does not apply to what has happened in the past, but it's applying to what will happen in the future. So we're adjusting our estimate to complete by the CPI. And then the final formula, this is where you want to consider both cost performance index and your schedule performance index. It is just a much more complicated way of calculating pretty much the same numbers, but you have definitely got to learn and know this formula as well for the exam. To get to your estimate at completion, you take your actual cost, you add to it your budget minus what you have earned, and then you factor in your cost performance index and your schedule performance index. Note, this final formula is very similar to the second formula that we have just above it, the estimate at completion at present CPI, but in this case we factor in the SPI as well. You can use this formula in a situation where a project is over budget, but you still need to meet a scheduled deadline. Remember our 6 questions that we wanted to answer? Well, so far we've only answered the first 2. Let us turn to the third question. If you recall, that third question was, what cost performance is required with existing resources to deliver our project as promised? This is precisely the question that another technique for forecasting aims to answer, and this is the To Complete Performance Index, the TCPI. This is the index that you must achieve in order to reach your cost target, and your cost target can either be the budget at completion or the estimate at completion. So the To Complete Performance Index, according to the PMBOK guide, is a measure of the cost performance that is required to be achieved with the remaining resources in order to meet a specific management goal, expressed as the ratio of the cost to finish the outstanding work to the remaining budget. To better explain what we mean by this, let's dive straight into an example. And let's assume that you are in Japan and you are driving from Tokyo, which is point A on this map here, to Osaka, which is point B. The distance between those 2 points is about 550 kilometers. So going at about 80 kilometers per hour, you expect that the drive should take you around 7 hours. So if you leave Tokyo at 8 o'clock in the morning, you should theoretically be able to arrive in Osaka at around 3 o'clock in the afternoon. Then at 1 o'clock in the afternoon, although you planned on having driven 400 Ks at this time, you check the odometer and to your disappointment it says, well, you've only driven 300 Ks so far. Armed with this information, you can now calculate your To Complete Performance Index for this trip. Let's first assume that you still want to arrive in Osaka at 3 o'clock as originally planned. This is equivalent to aiming for your original budget at completion. So you use your original arrival time. So you only have 2 hours left to get there. There are 550 kilometers less 300 that you've already driven, which means there are 250 kilometers to go on your journey. That means you must drive 250 50 kilometers in 2 hours, or you need to have 125 kilometers per hour on average so that you arrive there on time. So your TCPI based on your original estimate is 125 kilometers per hour starting right now. However, I visited Japan once, and if I'm not totally mistaken and remember this correctly, the maximum speed limit in Japan is 100 kilometers per hour. So that means that driving 125k for the next 2 hours isn't going to work, so we're going to have a new arrival time here. So let's assume that you and your family, you decide, well, we change our arrival time from 3 o'clock to 4 o'clock. This new arrival time is equivalent to a new estimate at completion. So your calculation now looks like this. You're targeting a 4 o'clock arrival. This means you now have 3 hours left to cover the remaining 250 kilometers. In other words, you must drive 250 kilometers in 3 hours. And if you calculate this correctly, it means you have to drive 83 kilometers per hour for the next 3 hours in order to reach your target. And that, of course, means your TCPI based on the new arrival estimate is 83 kilometers per hour. But of course, on most projects, you don't have to calculate how fast you're driving. Instead, you have to calculate your performance on the project in order to reach a specific goal. And the goal can either be that you want to reach your target based on your original budget, your budget at completion that you have set out to do originally, or you want to calculate your performance based on a new budget, your estimate at completion, an updated budget there. And these here are the two formulas on how you calculate this. If you relate this back on our original example here with driving through Japan, it's pretty much the same idea on how you calculate these numbers. Please note that the only real difference between these two formulas is that in the first formula you have the budget at completion twice, and in the second formula you use the budget at completion and the estimate at completion in order to calculate your TCPI. For completeness sake, let's take a look at the abbreviations for the TCPI formula. So we calculate the TCPI, which is the 2 Complete Performance Index. Again, the difference is by using the BAC, the budget at completion, as opposed to the EAC, the estimate at completion, from which we subtract earned value in the numerator, and then in the denominator we have the actual cost, which we subtract from the BAC or the EAC. And how do you interpret the TCPI? Well, when the TCPI is greater than 0, especially late in the project, getting back to the original budget at completion or estimate to completion would be very difficult. This result is a wake-up call. You need to take corrective action. And when the TCPI is less than or equal to 1.0, well, the project is performing as expected or even better than expected. This is a good situation. The project is being managed well. Continue to monitor the project, but there is no need for any corrective actions. Let us once again get back to our original 6 questions that we asked earlier on. I believe 3 are still unanswered, and there are 3 formulas to address these questions. They're so simple, you'll have no problem understanding these. We asked, what is the expected cost variance at completion? To answer this, there is the variance at completion, and this is calculated variance at completion equals budget at completion minus estimate at completion. The result of this formula is simply, if we take our driving example again, our original budget said we wanted to arrive in Osaka at 3 o'clock. We now estimate that we will arrive at 4 o'clock. So the variance, the difference is, well, 1 hour. Similar to cost variance, if VAC is greater than 0, then your project is under planned cost. If VAC is 0, then you are on planned cost, so you're good, nothing to do there. And if VAC is less than 0, then you are going to be over the planned cost. The next unanswered question was, how do I measure work achieved in terms of my approved budget? To address this, we have the percent spent calculation, where percent spent equals actual cost divided by budget at completion multiplied by 100. The result of this formula is once again simple. If we take our driving example, we left at 8 a.m. from Tokyo and we wanted to arrive in Osaka at 3 p.m. If it is now 1 p.m., that means we have used 5 out of the 7 hours that we had budgeted. So actual cost would be 5, budget at completion would be 7. If we plug these numbers in, we can figure out that 71% of our budgeted travel time has already been spent. The last question was, how do you estimate the amount of work completed to date? The earned value based formula that will give you this information is percent complete, and the formula you can see here, it is percent complete equals earned value divided by budget at completion times 100. Again, back to our nice little driving example. If you had 550 kilometers to cover the full journey, but so far you have only driven 300 kilometers, then at that point you are only 300 divided by 550, or about 55% complete. Let's review. Earned value techniques, they concern themselves with all the formulas around earned value management, forecasting, and the to complete performance index. You must know these formulas. You must study them. You must understand how they're applied, when they're applied, and you must answer as many sample questions as you possibly can in order to get good practice. Then you also have to know a lot of terms and abbreviation. Let's take a look at them. AC is the actual cost. This is how much our project has cost us so far actually. PV is the planned value. This is how much we had planned on our project, how much it should cost us up to date. And then we have the EV, the earned value. This is our theoretical value that our project would earn if we were able to sell the deliverables that we have produced so far. But you'll also need to know these terms and abbreviations here. CV and CPI. This is the cost variance and the cost performance index, and you have to know how to calculate these. You also have to calculate SV and SPI, the schedule variance and the schedule performance index. Then we have EAC and ETC, estimate at completion and estimate to complete, which both can be figured out with rather simple and rather complex formulas. Then we have a budget at completion, we have the TCPI, the to complete performance index, and finally a rather simple formula will give you the VAC, the variance at completion. The values behind these terms are used in various formulas for performance measurement and forecasting. In terms of interpreting the indices, you can tell if the result is good or bad based on whether it's greater than, equal to, or less than 1. For the CPI and the SPI, the cost performance or the schedule performance indices, if they are greater or equal to 1, they are good. In case of the TCPI, indices less than or equal to 1 are good. For the CPI and SPI indices, when they are below 1, that means they are bad. And in the TCPI's case, it's the reverse. If the TCPI is greater than 1, then we have a bad situation. You must learn and understand when to use which of the EAC formulas and how to interpret these indices. Now let's test what you have learned and try out this question that you might find on an exam simulator. Which of the following formulas is the EAC forecast for the ETC work performed at the present CPI? Is it A, AC plus bottom-up estimate to complete? Is it B, actual cost plus budget at completion minus earned value? Is it C, budget at completion divided by the cumulative CPI? Or is it D, this rather crazy formula here? The answer is, of course, that it is C, budget at completion divided by the cumulative CPI. And you might scream and say, wait a minute, the word cumulative has never appeared in any of the formulas that you have shown us so far. That's okay. The CPI is normally expressed as the cumulative CPI. So whether you see CPI or cumulative CPI, it usually means the same thing. This formula assumes that what the project has experienced to date can be expected to continue in the future. CPI is the cost performance index, and if the current project cost performance is likely to continue, then the estimate at completion can simply be calculated by dividing the budget at completion by our current cumulative CPI. Let me leave you with some exam tips before we conclude this lesson, because it's important for you to know the reason why we apply all of these formulas, and not just the formulas themselves, because if you don't understand the reason, then you have a problem on the exam. A typical exam question will describe a situation wherein you have to identify what the earned value situation is, and you then have to decide which formula best applies to the question. All these formulas for this earned value, by the way, and how and when you should use them, they belong onto your brain dump sheet, onto your cheat sheet. You have to know them, and you must be able to use them in calculations. And of course, there's really only one way to learn them, and that's to study. You have to practice, and answer as many sample questions as you possibly can in regards to earned value, to get to know the formulas and to understand them and to have practical application in using them on your exam questions. And of course, you need to learn them all by heart. And with that, we have come to the end of this lesson. So it's time for Justine and I to say goodbye.
Goodbye.
Goodbye. I mean, until next time.